Checking 1, 2. Checking. Checking. Okay, I think we're about ready to go. As usual, dealing with some technical difficulties that are 95% user error, operator error, basically. It's because I don't know what I'm doing. All right, so let's just jump right into it. We're going to do everybody's favorite, fractions. All right, let's see what happens. So some of the objectives we're going to try and figure out today are how to reduce a fraction to its lowest terms, how to multiply and divide them, and how to add and subtract them. Kind of basic stuff. So you know what a fraction is. It's a real number written as a quotient or a ratio of two integers, a and b. So you have a over b. The top is called the numerator. I need a better way to, I think, write numbers. Numerator, write numbers, I mean, write words. Anyway, it's called the numerator. This is called the denominator. D-E. I'm just going to shorten it to denom. But it's the denominator, I guess. Let's just write the whole thing. There you go. Look at that beautiful penmanship of the year right there. So the number above the fraction bar, this would be the fraction bar, is the numerator. The number below that is the denominator. Numerator and denominator. It's like a German techno song. The numerator is often called the part, and the denominator is often called the whole. So, with that in mind, if you had something like 3/4, you would say you want 3 parts of 4. I've never really looked at it like that, to be honest. So equivalent fractions are two equal ratios expressed using different numerators and denominators. So if you had 5 over 10, that is equal to 1 over 2. So those are the same thing. Decimal form, I forget about the circle, is equal to 1/2. And in decimal form, that would be 0.5. An easy way to look at it too is quarters, 50 cents, half a dollar. It's half, 0.5. So what that's saying is, 50 parts, or 50, that's a 5. 5 parts out of 10 is the same as 1 part out of 2. So if you have something like, let's see, what would be another version of 1/2? 40 over 20. No, 40 over 80. So this is also 1/2. And you could say they have equal or common factors of, let's say, 10. So you could rewrite this as 4 times 10 over 8 times 10. So 10 would be a common factor in there. So then what you do next is anything over itself is equal to 1. So x over x is equal to 1. So you can rewrite this part as basically as 4, 8 times 1. And that's going to equal 4/8. So when you do this, when you replace this factor of 10 over 10, x over x equals 1, the process of doing that is called canceling. And the steps for finding equivalent fractions it's going to define the process of what we call reducing. So even 4/8 can be reduced more. Another way to reduce, so what's a common factor before we go to the next section? So let's reduce this some more. What's common factors in here? 2, so you'd have 2 times 2. Oops, and then 4 times 2. So now that 2 over 2 is the same as 1, we can go 2 over 4 times 1 is equal to 2 over 4. Then in a common factor in all of this is 2 once again. So we would have 1 times 2 over 2 times 2. That part's equal to 1 because it's factor over the same factor. So we're left with the 1/2. Now another way to do all of this is that we learned the last time is to break it down into primes. The product of primes. So the 40, what are the prime numbers in 40? So you have 2, times 20. 20 breaks down to 2 times 10. Oops. Two is done. 10 goes to 2 and 5. So now you can and then 80 would be 2 to 40. And then 40 we know is 2, 2, 2, and 5. So we're just going to add an extra 2 on the bottom. So we'd end up with 2 times 2 times 2 times 5 over 2 times, and then this stuff again. So 2 times 2 times 2 times 5. I should have probably lined this up better, but let's line this up better so it makes sense. So with the factoring out, what we learned up here, x over x equals 1. We have 1 here. Oh, darn, I was hoping not a full circle would erase it. So that becomes 1. This becomes 1. This becomes 1. This becomes 1. And then we still have the 2. So these are all turned into 1. So we basically have 1 equals 1 on top. So 1/2. So that's just kind of a quicker way to do this. There's going to be, we're going to learn quicker ways than this too, for sure. So then another way of doing this is finding the greatest common factor of the numerator and the denominator. So like that example we had up there of 40 over 80. 40 would be the greatest common factor that goes into both of these. So 40 goes in that one, it goes in 80 twice. Simple way of doing it. Let's think of something though where, how about if we had 45 over 75? So we know 5 goes in there 9 times. 5 goes into 75. 25? 15 times. So yeah, actually, you know what? 15. Now that I think about it, 15 is the greatest common factor in here, and it would go in to 45 3 times. And then 15 goes into what? 64 times, so that'd be 5. So it would equal 3/5. So according to the book, I kind of jumped ahead there. So yeah, let's go back to the 30, what were we doing? 45 over 75 example. And we want to know the factors of 45. We have 1. See, does 3 go into 45? Yeah, 3 goes into 45, so 3. 5. And then 9, 15, and 45. Now the factors of 75 are 1. 3 also goes into 75. 5 goes into 75. I don't believe 6 does. Nope. 7 does not. 8 does not. 9 doesn't. 10, 11, 12, 13. So 15, I believe, is the next one. And then 25 and 75. So what we're looking for is the highest number that's common to both. So it's not 1 because we have 3. It's also not 3 because we have 5. Next number here is 15. Here's a 15, 25, and so 15 is the highest. Common. So now we got to find out how many times 15 goes into 45. We can use this little chart we drew right here because 1, 3, that's what equals 45. What equals 75? 1 and 3, 3 and 25, 5 and 15. So we know 15 goes into 45 3 times. And we know that 15 goes into 75 5 times. So 3/5 is your answer. So let's take 105 over 300. And we want to reduce this. So whenever you're doing the math too, it's do your work. Like we can do this in our head and figure out that we have, let's see, on 105 we would have 7, 3, and 5 would be breaking it down to primes, product of primes. But if you're watching this, then you're probably a beginner too, so just break things down. So let's see, 5 goes in there 25 times. No, that's not 25. Yeah, it is. It's 3. $21 times. I knew I was off a little bit. And then 3 and 7. So I'm going to make a lot of little common mistakes like that because this is all refresher for me from billion, zillion years ago. So we're going to end up with 3 times 5 times 7 over, and then what do we get for 300? For 300, we're going to get 2. Remember, it's an even number, so you can always do that. And then we're going to go to 150. 150 is also even, so it goes 2, 275. $75 is going to be 3 into 25. And that's going to be 5 and 5. So now we've broken down both 105 and 300 into the product of their primes. So this is all prime numbers here. 2. So we're going to go 2 times 2 times 3 times 5 times 5. So one set of 5s will cancel out. One set of 3s will cancel out. And we're going to be left with 7 over 2 times 2 times 5. Now you still got to multiply this out. So what do we have? That's going to equal 7 over 2 times 2 is 4. 4 times 5 is 20. So 7 over 20. Now another thing you can do with this is you factored out the product of primes, then multiply the ones that are getting canceled out. So look what you have. 3 times 5 is 15. On the bottom you have 3 times 5, that's 15. Which, I mean, those are canceling out, so it should be equal top or bottom. But the 15 equals the greatest common factor. So remember earlier when we factored everything out and we had 15. So instead of doing all these steps, you could just say, okay, 15. So what does 15 go into 105? That's 7. 15 goes into 320. So that's another way of doing it with the greatest common factor. Okay, now we're going to get to improper fractions. This kind of can trip people up sometimes, but these shouldn't be too difficult. So the last time we had the numerator was smaller than the denominator. It's 3 over 4, 1/2. So now what's going to happen is on an improper fraction, the numerator is going to be greater than the denominator. So we'll have something like 4 over 3, 2 over 1. And then you can also get and then what you want to do is convert. You want to convert these into mixed numbers. So 3 goes into 4, so you're basically going to do division. So you have 3 going into 4, and it goes in 1 time. Then you have 3. Then you minus 3, and you have 1. So what that's gonna change to is your answer on top here, 1 becomes a big number. This becomes your new denominator. Oops. So it becomes 1 and 1/3. And to make that make sense, let's take a number line. Not that one. That's a number hill, cliff. That's close enough. The number valley. And if we divide it into thirds, so let's say, let's make this 0. Let's make this 1, and this looks like approximately 2. Now if you divided it into thirds, these thirds aren't to scale. So if you had 1/3, you would have an area that fills up this space. Wow, everything's just an erase, huh? Wow, unbelievable. Okay. So here's 0. here's 1, here's 2, here's the thirds. So 1/3 would fill in this area. If you had 2/3, it would fill in this area. 3/3 would fill up that whole area. See, that's why you have x over x equals 1. Because look, in this example, you had 3 over 3. That equals 1, because this is 1/3. 2/3. This is 3/3. Oh my gosh. Now 4/3. So another way of writing 4/3 is, here's 1. So you have 1 plus another third. 1 and 1/3. Let's do something a little more difficult here. Let's do, let's say you had 23 over 5. So you want to do little division. So 5 goes into 23. So 5 goes into 23 4 times. That makes 20. And you have 3 left over. This is where you want to stop though. Like in traditional algebra, you would drop a 0 down and say 5 goes into 30 6 times. You would draw a point here. So you'd have 4.6. We're just doing the fraction. However, 4.6 is the correct answer for this. I'm going to show you something here too. I said traditional algebra, traditional division. So let's not worry about that. So now 4 becomes this number. 3 becomes the numerator, so the remainder becomes the numerator. And the 5 stays as the denominator. So now we have 4 3/5 instead of 23/5. Now, here's something I wanted to show you. If you divided something into fifths, each section is 20%. So think about this as 0 to 100 or $1. So this is 0. This is 100. Let's say it's $1. And you had 2 dimes. So how many dimes can fit inside of this? 10 of them. So 2 dimes would be the same as 1/5. So 2 dimes is equal to 20 cents. So 0.2. So when you have 4 3/5, you're filling in 3 of these. So it's 40 cents or 40%. And this is 60 cents. Or 60%, 60 out of 100. So remember up here, if we finish out the division problem, we get 5 goes into 30. So it's 4.6. Well, look where we ended up at 0.6. So it's the same answer, just different ways of doing it. Hopefully that makes sense if you're watching. It makes sense to me, so I'm going to continue on. Sorry. So now let's do the reverse. So let's take the mixed number and turn it into an improper fraction. So here we have 3 and 5/7. So we want to end up with an answer that's just x over 7. So that's the one common thing between these, is the denominator is always going to stay the same. So what we're going to get here is 3 over 5/7 equals, we're going to multiply 7 times 3, and then we're going to add the numerator. That's going to go over 7. So 7 times 3 is 21. And we're going to add 5. So that equals 26. So your answer is 26 over 7. I always love, let me see if I can put a square. Still erases it. I need to mess around with this if there's a way to. I love circling the answer. And this tool erases it. So pretty simple. We'll do one more, because I know this is something people struggle with. Let's do 4 over 7/9. So remember, the denominator stays the same. So it's going to be over 9. We're going to multiply the denominator by the whole integer there, 4. So we have 9 times 4. And then we're going to add the numerator. So 9 times 4 is 36. Over 9. 36 plus 7 is going to give us 43. So it's 43 over 9. Now if I give you 43 over 9, let's work this backwards. So remember, the numerator is always the same. And what we're going to do now is do a 9 divided by 43. So 9 goes into 43. Let's see. 36 4 times at 36. And that's going to equal, let's see, 43 minus 36. That should equal 7. And that's going to give us, remember, this becomes our whole number. This is our denominator, and this is our numerator. And look, right back to where we started. Full circle. So this is separate from the reducing process too. So note, so if you have a fraction that you can reduce, so if you think you should reduce it first, then go ahead. So if you had something like, let's say 4 over, let's see, let's just keep it easy. We're doing 4 over 50 over 100. I mean, you could do the, you know, you could go 100 divided by 50. Oh, I guess we're doing it the other way around. Excuse me. You know, if you want to multiply, see 9 times 4. If you want 100 times 4 plus 50, so you're going to end up with 450 over 100. Sorry, I'm watching baseball and the Dodgers just tied it up. Okay, so you have, then you'd have to go through reducing that, and you're like, oh man, I don't want to reduce all that's a big ugly number. So reduce this first. We know 50 over 100 is going to be the same as, I mean, you can do all the work, but it's going to equal 4 and 1/2. Now we can do this again. We can say, oh, this is a lot easier. 2 times 4 is 8 plus 1 is 9 over 2. So much better than having that 450 over whatever we had. Okay, now let's multiply some fractions. So let's say we have 2/3, and we want to multiply it by 5/7. It's pretty straightforward. It just equals 2 times 5 over 3 times 7. And that's going to equal 2 times 5, 10. 3 times 7, 21. 10 over 21 is your answer. So the rule on this is A over B times C over D equals AC ACBD. We all know their songs. So pretty straightforward on multiplying. Now let's do something a little tricky. What happens if you have this? 5 over 9. What are you going to do here? Well, by this rule, we're going to have 5 times 1 over 9 times 4. But we're multiplying a positive times the negative, so we know what that means. This is now negative. So your answer will be negative 5 over 36. Still pretty simple. Now, what happens if you get something like this? Let's see. If you have 2/3 times 5 over 3/4. Well, let's just make this an improper fraction first. So to make this an improper fraction, we know to multiply the 5 and the 4, add the 3. What is that? So 4 times 5 is 20 plus 23. So it now becomes 23 over 4. Now we can go back to making this 2 times 23 over 3 times 4. 2 times 23 is going to be 46. 3 times 4 is going to be 12. This is obviously can be reduced. So what would be an easy way to reduce this? Let's go back a step. Oh, 2 and 4. So you can almost rewrite this you don't have to rewrite this, but you can pretty much say 2 over 4 times 23 over 3. What does this reduce to? 2 over 4. That's going to reduce to 1/2. So now you have 23 times 1 equals 23. And 2 times 3 is 6. So now we have 23 over 6. And if we want to turn this back into, 6 goes into 23 3 times. And 3 times 6 is 18, so that gives us 5 remainder. That 5 becomes the numerator. So it breaks down to 3 and 5, 6. Almost 4. So when we do something like this, it's called cross-canceling. So when you're going, okay, 2 goes into itself once and 2 goes into 4 twice. Cross-canceling. But you can do this too. So now we want to know what a reciprocal is. So two real numbers whose product is 1 are called reciprocals. Therefore, a times b and b times a are reciprocals because a times b times b times a equals ab equals 1. That b should not be. So, how do we prove this? So that should be written like that. Actually, let's do this. So if you have a times b over b times a, you can rewrite it as ab multiplied by ba, and that will equal 1. Now here's your example. So we have 2/3. We take the reciprocal of 2/3, so a and b, so 2 would be a, 3 would be b. And we flip it over. 3 over 2. Now we're going to multiplying this. So 2 times 3 is equal to 6. 3 times 2 is equal to 6. And we know that x over x is equal to 1. So that's a reciprocal. So let's do a couple more reciprocals because it might be tricky and what I'm saying is not making sense to you, but this is making sense to me. So let's say we have 5/8. The reciprocal of 5/8 would be the b over a. So we have 8 over 5. Multiply those together. And you're going to get 40 over 40. So that equals 1. Because think about what you're doing here. So let's say you have 7 and 1/7. So 7 can be rewritten as 7 over 1. So the reciprocal of 7 is 1/7. So if you notice, what you're doing when you do the reciprocal is you're flipping over and multiplying. So doesn't matter what order you multiply in. A multiplied by B equals B multiplied by A. So when you take this fraction and you flip it over, you have the same multiplication problem on both sides. So you're always going to equal 1. So now let's do 2/3 divided by 5/7. That's just a different way of writing. So what we have here is you're going to take the reciprocal. So you get 2/3. You're going to change this to the multiplication and take the reciprocal of 5/7, which would be 7/5. And now we can multiply. So now we have 2/7 over 3/5. That equals 14 over 15. So this and this both equal divide. So when you see fractions, it's basically asking you to divide. So if you see 3/5, it's asking you how many times does 5 go into 3? 5 goes into 3 0 times. It goes into 36 times. So it goes in 0.6 times. That's 3/5. Remember the example I gave earlier. Oops. Number line divided. Here's 0. Here's 100. Let's divide it into fifths. So you'd have 0.2, 0.4, 0.6, 0.8. And then 1.0, 100, whatever you want to call it. So 3/5, 1, 2, 3, 0.6. So I think what trips people up a lot too on math is just different symbols, not knowing that a fraction is basically a division problem, or it's asking you to divide. How things correlate with each other. I think if that was more time spent doing that, I think kids would probably be more successful at math. Instead of looking at this going, what does it mean? You just know automatically, oh, that's division. Depending on how I'm using it, I can leave it as a fraction, or I can, let's see if this erases. Yeah. I can leave it as a fraction, like, if you're measuring, you need 3/4 of an inch, leaving it, or let's say 3/5 of an inch, it's already up there. Just saying, hey, I need 4 3/5 inch of wood cut. That's fine. You might want other things where you convert it to 4.6. Maybe if you're doing like how many, points someone was averaging a game or something. I mean, it's kind of like Mexican food. The ingredients are all pretty much common, but you can mix and match them to make 100 different dishes. So let's say we have this 7/8. Here's an example of how things can just be written different ways. 2/3. You're like, oh man, this is so confusing. This is equal to what we just did on the last problem. Now that you know this can be rewritten as this, and we just saw how to do this, you go, oh, I need its division. I need to take the reciprocal. So now we can make this a multiply. The reciprocal is 3/2. Now we have 7 times 3 is 21 over 16. And then what can we do with 21 over 16? We can say, hey, 16 goes into 21 one time. That's our full integer. We have 5 left over. That becomes our new numerator. And we end up with 1 5/16. Either or is correct. This wouldn't be correct, though, if they asked you to turn it into a mixed number. Then you would have to do that. So if you write it this way, there's not really a teacher that's going to ding you out for writing it that way, or for not writing it this way, unless they specifically ask for it. Okay, let me clear this out. So now we have 5 squared over 7/4. And we know that we can just write it as 5/2 divided by 7/4. And then that becomes 5/2 multiplied. I shouldn't use an x here. That's going to be 4/7. Now at the step, we can do some reducing, some cross multiplication, or cross canceling, excuse me. 2 goes into 2 one time, 2 goes into 4 twice. So now we're going to multiply 5 times 2 instead of 4, and we end up with 10/7. Now, if we didn't reduce, what we'd end up with? We'd end up with 5 times 4 equals 20. 2 times 7 equals 14. Now, these are both even numbers, so we know we can reduce them by 2. So what? 2 goes into 20 how many times? 10. 2 goes into 14, 7. So it's the same answer. Unlike the last problem, if you left your answer like this, you'd probably get some points taken away for not reducing. If I click things off, pause is your friend. Okay, so now let's say you get a problem like this. 2/3 divided by 6. To make things easier for you, you may want to rewrite this as 2/3 divided as 6/1. And then you can just follow what we've been doing along the whole time. So 2/3 times 1/6 equals 3/18. Whoops, remember what I said, we can redo. 2 goes into itself one time. Let's cross cancel here. Goes in 3. So now we have 1 times 1 equals a 1. 3 times 3 equals 9. So 1/3 times 1/3 equals 9. Or 1/9, excuse me. So 2/3 divided by 6 is the same as 1/9. Now don't do your cross canceling before you change the reciprocal and make this a multiplication problem. If you do this while you're still in the division and you go, oh, 3 goes into itself once, goes into 6 twice. Now let's do the reciprocal. We have 2/1 times 1/2. We end up with 2/2 equals 1. So it's not as happy as it looks. That's not right. So make sure you don't cross cancel until you've changed the reciprocal and turned it into a multiplication problem. So when you're subtracting fractions and adding fractions for that matter, you have to have a common denominator. So something like A over C plus B over C is equal to A plus B over C. And subtraction, A over C minus B over C equals A minus B over C. So let's subtract. So let's subtract 12/15 minus 3/15. So what do we get here? We get 12 minus 3/15, which is equal to which is equal to 9/15. Now 9/15 can be reduced. Whoops. What am I doing with this 9 here? So what is the common factor of both of these? 3. So if we divide 3 out of both of these, we're going to end up with 9 divided by 3 is 3. 15 divided by 3 is 5. So we end up with 3/15. Okay. Sorry. Got distracted by baseball again. So let's do for the next problem. Let's subtract 7/15 minus 3/10. So if you notice, our denominators aren't the same. So what happens when our denominators aren't the same? So we need to find a common denominator. And we want the least common multiple. So before we were looking for the greatest, now we're looking for the least. So if we do the set of 15, so what? Okay, so multiples of 10 are going to be 10. Sorry, I had to read over a little bit because in my mind I was going to do this all wrong. So we're looking for multiples of 10. And that would be what? You'd have 10. Let's see, technically you want to write it as a set. 10, 20, 30, 40, 50, 60, etc., etc., etc. Multiples of 15 are going to be 15. What comes next? 30. 45. 60. We'll stop at 60. So we have two that are common, 30 and 60. We want the least one, the lowest one, so that'd be 30. Oh boy, I'm about to erase again. So now what we need to do is change these denominators into that common one we found, which is 30. To get to 30, though, we have to multiply. So what do we get to 30? Times 2. So 15 times 2 is equal to 30. And it's 10 times 3 is equal to 30. So we must multiply both sides by 2. So we're going to end up with 14, 30, because 15 times 2 is 30, so that henceforth 7 times 2 is 14. Now minus. So to get the 30 with the 10, we need to multiply by 3. So that gives us 30. 3 times 3 is 9. Now what we can do is, remember now it's 14 minus 9 over 30. 14 minus 9 is going to equal 5. 5 over 30. Now we need to reduce. So the common multiple, or whatever, I forgot what it's called. Oh well, it's 5. 5 goes into 5 one time. 5 goes into 36 times. So the final answer is 1/6. I forgot the term already. So I'll do one more of those just so it makes sense. So let's say we have 9 elevenths minus 3/5. So what is the smallest number that both 5 and 11 can go into? So 5, everything in 5s is going to be multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. 11 times 2 is what? 22, 33, 44, 55. So 55 is going to be the smallest common factor that they have. So to get to 55, you have to multiply by 5. And 5, obviously, based off of that, you have to multiply by 11. So you need to do the same thing up here. So 9 times 5 is 45 over 11 minus 33 over 11. So that's going to be 45 minus 33 over 11. That's going to be 12 over 11. Now remember, since the numerator is greater than the denominator, it's improper fraction, we could change that to a mixed number. So 11 goes into 12 one time with a remainder of 1. So 1 and 1/11. So let's do, I don't think we've done an addition yet. So let's do 5, 10 plus 1/18. So we're going to do the same thing. So what's the common denominator here? So we know 10s are going to be 10, 20, 30, 40, 50, 60, 70. So 18 times 2 is 36. Times 3 is 54. times 4 is 72, times 5 is 90. So that's going to be times 5 and times 9. So 90 is what they have in common. So whatever we're multiplying the denominator by, we have to multiply the numerator by. So that's going to be times 9. This will be times 9. This is going to give us, this is a 9, not a 4. So 9 times 5 is 45 over 90. That's going to be 9 over 90. Oops, not equal. Plus. And this is going to be 45 plus 9 is 54 over 90. And this can reduce. Let's see, 54, what would 54? That'd be 27. So these can both be divided by 2. That's going to be 27 over 45. Guess what? That can reduce more too. 3 is going to be, oh, that can reduce by 9. Actually, this can reduce by 9 also. So 3/5 is your answer on this one. Okay, so I did something wrong. Let's see, 45. Oh, this is times 5. Okay, that's where I went wrong. 5. So it's 49 over 90. 49. Wow, 50 over 90. Let me just screw this up as much as possible. So 5 can go in that 10. Well, that's actually divided by 10, so 5/9. There you go. That's the correct answer. Okay, let's do something a little more confusing. So let's say we have something like this. So first let's take this mixed and make it into an improper fraction. So how do we do that? 3 times 2 plus 1. 7/3. So now we have 7/3 plus 3/5 minus 1/2. Now we need to get the denominator to be common. And let's see, what's the number that they all have in common here? It's going to have to be an even number, we know, because it's 2. We also have a 5 in here. So we know it's going to have to be 5, 10, 15, 20, 25, 30, 35, 40. So it's going to have to be a multiple of 10 because if it ends in 5, that's not going to work with the 2. So let's see what number we have here. 10 won't go into 3. 20 won't go into 3. 30 will go into 3. So 30 is the number we're looking for. That's the common, least common. So to get the 30, we need to multiply 3 by 10. That means we need to multiply 7 by 10. So we're going to have 70 over 30. To get to 30, we have to do 6. So 6 times 3 is 18. Minus 15 over 30. So we can rewrite this as 70 plus 18 minus 15 over 30. So we go, for simplicity, it's best to work from left to right. Say 70 plus 18 is 98 minus 15. But if you can keep track of what you're doing, 18 minus 15 is 3. 70 plus 3 is 73. And that's going to go over 30. Now, obviously, that's an improper fraction, so let's switch it to a mixed number. 30 goes into 73 two times, because 2 times 30 is 60. We have 13 left over. There you go. 2 and 13/30ths is our answer. Beautiful, huh? So the reason you don't want to end with 73 over 30 is because it was a mixed number represented in the problem. So you want the answer to represent what was presented to you. Piece of cake. So let's do a little word problem here, because everybody loves word problems. So you can see how this can be used in the real world. So the question is asking us how many 12-inch thick paperback books can be stacked to fit on a shelf that is 1.5 feet in length, or excuse me, in height. So first we want to determine the height of the shelf in inches. So the height of the shelf is 1 and 1/2 feet. Word problems, it's important to label what you're doing. So we want to know how many inches this is. So we know that 12 inches are in a foot. So we have 12 over 1. Now this is multiplication. Let's make this into an improper fraction first. So 2 times 1 is 2, plus 1 is 3, so it's 3 over 2, times 12 over 1. Now we know we can cross cancel here, so 2 goes into 2 one time, goes into 12 6 times. So 3 times 6 is 18 over 1, which is the same as 18. And we wanted to know how many inches were in a foot and a half. 18 inches. So the next part of the problem is to determine how many notebooks will fit by dividing the height of the shelves by the thickness of each book. So our books are 12 or 1/2 inch thick. So we have 18 inches. We want to know how many 1/2 inch books can fit into 18 inches. So we're going to divide by 1/2. Now, what do we do here? We want to make this a multiplication problem, so we need to take the reciprocal of 1/2. What is that going to be? 18 times 2 over 1, which is the same as 2, which is equal to 18 times 2. Now remember earlier, all we have is a basic multiplication problem now. So there's other ways we wrote that earlier. 18 parentheses 2 Okay, if you see this, it's the same as this. 18 times 2 is 36. So we can fit 36 half-inch books in an 18-inch shelf. So what did we learn today? We learned that fractions are not unique, that there are many ways to express the same ratio. And we can find equivalent fractions by multiplying or dividing the numerator and the denominator by the same real number. It's good practice to always reduce. It makes things a lot easier. In algebra, remember, improper fractions are generally preferred. However, in real-life applications, mixed number equivalents are often preferred. So you can represent the answer, like I said earlier, as an improper fraction unless specifically asked for, or if the original question contains mixed numbers, or if it's the answer to a real-world or geometric application, like if you're having to cut a piece of lumber, and you need to know, and somebody said, hey, I have two links that really are just one piece. I need 3/4 of an inch plus 5/7 of an inch. So you need to figure out what that is. So we need to get these to be common. So 28. So we have 21 over 28. To get to 28 is 4. Plus 4. So 20 over 28. That equals 41 over 28. 28 goes into 41 one time with, let's see, how many's left over on there? 30 would be 11. What is that? 13. So you would know you need to cut your piece of lumber to 1 and 13/28. And there you go. Remember, multiplying fractions does not require a common denominator. And it's best practice to cancel any common factors in the numerator and denominator before multiplying. So if you have 2/5 multiplied by 3/8, you're going to want to reduce this first. So instead of going to it's 6 over 40, just go, let's see, 2, and that'd be 4. So now you can come up with 3 over 20 instead of 6 over 40. Eventually you're going to have to reduce, so it's easier to do it when it's obvious than ending up with 6 over 40 and going, oh, what are all the common things that go in there? And then always divide fractions by multiplying the reciprocal of the divisor. So what does that mean? 1/4 divided by 3/6. This is the divisor. It's the same as writing it as 3/5. 1/4 divided by 3/5. This is the divisor. Remember, change it to multiplication by doing the reciprocal. Now, can we reduce anything in this? 1/3, 4/5? Nope. So we end up with 1 times 5 is 5. 5/12. And then this is a proper fraction, so that's the end of that. So when you're adding or subtracting, though, it does require that the denominator be the same. So if you have 3 let's just put xy. Sevenths. To get to the common, let's see, they both have 21 in common. You'd have to multiply by 7. And you have to multiply by 3. You need to multiply by this by 7 and this by 3. Whether you are adding or subtracting. So then you have x times 7 over 21 plus y times 3 over 21. And then you can add these together. So if the x was 4, y was 2, you know, you'd have 6, 28 plus 6. And that's about it. I think we're done. This is pretty simple and easy stuff. All right. Until next time.